All right, we're going to review how to look at a relation and determine whether or not it has the characteristics necessary to be considered a function. In Algebra 1, you should have looked at the representations of relations, the graph representation, the ordered pairs, the tables, and the mappings, and use those to determine if the relation was a function or not. We're going to add the Algebra 2 element by including the representation of an equation. So we're going to look at equations also to determine if it's a function. So just to review, a relation is just a group of points. We're considering this group of points as a group. So any group of points can be considered a relation or called a relation. If that relation has a characteristic where each x is matched to only one y, then that relation can also be called a function. And the way you determine that depends on which representation of the relation you're looking at. When you're looking at tables, you're looking to see if your x values repeat. Here we have these x values repeat. This 3 maps to 1, this 3 maps to 6, or is matched with. The 3, which is an x value, is being repeated and it has two different y values. So for this one, we would say it is not a function because the 3 repeats, it's being repeated. Same idea here for the mapping. The only difference is with the mapping, we're looking at the arrows. This is the ordered pair -7, 2. This is the ordered pair 0, 2. And this is the ordered pair 3, 1. We see that each x value only maps to one y value. So we say, yes, this is a function. Each maps to one y value. Now, it may bother some of you that this -7 maps to 2 and 0 also maps to 2, but remember, we're not interested in whether the y's repeat. We only care that the x's repeat, okay? So if each x only has one arrow coming off of it, then we're good with that. Same thing is true with the ordered pairs. It's the same thing as a table. They're just written down horizontally rather than written down vertically. So you look at the x values, and if they're all different, then it is a function. So we don't have any x values repeating. This is the same thing. We can't have any x values repeating. The only difference is our ordered pairs are not written down. Our ordered pairs are drawn for us. So we do, for graphs, this thing called the vertical line test. And if you can draw a vertical line anywhere on the graph, and that vertical line touches your group, your relation, if that vertical line touches your relation in more than one spot without moving, then it fails the vertical line test and we say it is not a function. Now let's look real quick and understand this ordered pair right here, and I may be estimating it just a little bit, but it looks like these x values are -2. So we see that we've got an ordered pair right here. That looks like it's the ordered pair -2 and then 1, 2, 3, -2, 3. This point down here looks like it's the ordered pair -2, -2. Okay, and so we're just demonstrating right here that we've got an x value -2 repeating. This -2 maps to the 3, this -2 maps to the 2. So if we did a mapping, our x values would just be -2, our y values would be 3 and -2, and it would map to both of them. So our x value would have two arrows coming off of it. So it fails the vertical line test. With equations, you kind of have to pay attention, and you're going to get better at this as we practice. Is it solved for y or not? If it's solved for y, that means y is by itself, and you don't have a plus or minus in front of it. If it's just a plain old ordinary y, I don't really care about all the x values and the constants and all the other things. If y is by itself, then it's a function. If the y is not by itself, then you're going to have to look at the exponent for the y to determine if it is a function or not. If it's not solved for y, and I'll give you some examples, if it's not solved for y, then the exponent on the y has to be odd in order for it to be a function. So is this a function? Yes, because it's solved for y and there's no plus or minus in front of it. I'm going to give you some other examples of those right now because the equations, like I said, are the newest ones. So we're going to do those examples first, and then I'm going to jump over and let you do examples of the other representations. So we see this one. Let's look at the ones that are solved for y. This one's solved for y. This one's solved for y. And this one's solved for y. And what I mean by solved for y, the y is by itself. So when the y is by itself, we're pretty good chance that it is a function. But then you have to check and make sure that there's not ways to get the same y value with two different x's, or the same x to get the same y value. So we don't see a plus or minus in front of this part of the expression, so this is a function. This one right here is a function. There's no plus or minus sign in front of that, so this one is a function. This one right here, we're solved for y, but do you see that we have a plus or minus right here? So when we plug in an x value right here, we plug in that x value and we work this out. One time the answer is going to be positive, then we have to plug it in again, that same number, and we have to stick a negative sign in front of it. That's what that means. So the same x value is going to give us two different y values, a positive one and a negative one. And that's pretty much what that circle looks like. That's how we get this. This is an equation of a circle, solved for y. So this plus or minus sign is what you have to look at. Now this one, some people might say is solved for y, but it has those absolute value bars in front of it. So you guys understand what absolute value bars mean. That means if I plug in a -3, and I take the absolute value of that, I get 3. If I plug in a +3 and I take the absolute value of that, I still get 3. So here we have, these are the y values, remember, and this is an x value. So I have one x value that's mapping to two different y values, a -3 and a +3. So one x value mapping to two different y values. So this one right here is not a function. So you have to look out for y values that are in absolute value bars. And then here we have some that are not solved for y because we have a y and an x on the same side, a y and an x on the same side. So the notes told you to look at the exponent. If it's even, it's a function. And if it's odd, no, I just did that backwards. If it's even, it's not a function. And the reason it's not going to be a function is because when you have an even power and you take this, and you're solving for that, you take the fourth root of both sides, you're going to have a plus or minus. If it's odd, however, this will be a function because odds do not have that same characteristic. Now, I don't expect you to understand why this one's going to have a plus or minus right now. That'll be something that we learn throughout the school year. Right now, all I want you to see is that if it's not solved for y and y has an even exponent, it's not a function. If it has an odd exponent, it is a function. All right, so I'm going to give you a chance now to practice the other representations. So you should take a look at this, pause the video, and see if you can answer these questions. And then when you think you've got them answered and explained, turn them back on, and I will have the answer key provided for you. Here's the answer key, and it shows each answer, and it gives an explanation. Look at the x's. No x values repeat, so it is a function. Look at the x's. This x has two arrows coming off of it, so it repeats, therefore it's not considered a function. Look at the x values. All the x values are unique. They are not repeated, so it is a function. This one fails the vertical line test. Here is another page where you can practice, and we will go over this at the beginning of class, maybe as a warm-up.